Hello. I'm going to start by noting that there is a car horn / siren going on here that I'm not going to wait for it to stop, just so you know that's coming from this video and you're not hearing it in real life. Today we are going to do some weapons. We already have a weapon, but it's kind of built into our player, and I want to separate it out. And then once we separate it out, we can make different weapons and let you kind of switch between them and have them given different properties and stuff like that. And I want to kind of focus on making systems that let us create content in a way that's pretty easy to understand, so that after I taught you the system, you can go and create the content. Or, you know, add any content that might occur to you and tailor it to your tastes. Before that, though, we have... I want to fix a bug that we have with our death explosions that we added recently. And I think I have a couple of errata. I told you that when I talked about lerp, lerp takes... You give it a minimum and a maximum, and then you give it a fraction, and it'll find where in that range that fraction would take you. I said that you could feed it values over 1, and it would, proportionally scale. That's actually not true. There's a separate function for that called lerp unclamped. Is that it? Yeah, lerp unclamped. Like I say, it almost never comes up, so you probably don't need to know that, but I did say that and it's wrong. And what was the other thing? I made a big deal of how you got to write fixed delta time instead of just delta time if you're working in fixed update. Good news, don't worry about it. Actually, it turns out you can just write delta time, and it will always use the correct value. It knows, we're in fixed update, I'll use the fixed delta time. And in fact, Unity themselves recommend you just use that all the time. So my knowledge is outdated there. A couple of little things. Those are both pointed out in the comments, so thank you for people pointing those things out. I learned a lot from doing this tutorial. And another thing that was pointed out in the comments is that our explosion... I said that this scale is 555. Our code now tells it to start at 0 and go up to 555. And so I said it doesn't matter what's written here. Actually, I think right at the very start, when they're being spawned, they are being created at 555, and that's not a good thing because... let's change it all to 0. This is the scale of our explosion prefab that we found in our project folder. So that it starts not being invisibly small, and then it's going to grow to its full height. The reason I think that might be significant is I wasn't noticing any visual problems, but I think there could be a code problem because our explosions hurt things when they hit them, and the way we're detecting that is with this function onTriggerEnter. And I hadn't really thought about this, but actually that could probably trigger as soon as we instantiate it. And the bug I want to fix is that we have a potential kind of infinite loop here. It's possible. I tried making... In fact, I'll do it now because I think it's a good change. I tried editing the enemy prefab. I wanted them to be a bit smaller, so I just kind of, with the size tool here, shrink them in the vertical dimension and then just sort of shrink them overall. And then if we play our game... they're kind of small. It's kind of nice. Might have made them too circular there because they're no longer tumbling, which is a kind of nice feature of them. And I made loads of them come out, so we can go back to our enemy spawner in our scene and change the seconds between spawns down to something like 0.2, and if we play that, we'll see they get churned out. These are just sort of cosmetic changes, really. And that's all well and good, but I didn't shoot them just then, because if you do, it can cause Unity to completely get jammed up. And it sort of looks like a performance problem. It looks like your game, it's doing too much, and you're stretching Unity too much, and it's you need to make your game simpler. It's not that. The performance problem is really serious, and what we're trying to do is not that ambitious. And so I looked into it, and I realized that I believe if you have densely packed enemies, the explosion from one kills the next one, or it calls this in our onTriggerEnter event, where when we detect that we hit something, if it has a health system, we tell that system to take damage, and I just control clicked there to go to the function that I clicked on. So now we're in a health system, and that take damage function creates a new explosion, and that explosion, I think, can run onTriggerEnter right away. Before we've even done another update of the game, it's running onTriggerEnter, which could hit not just another health system, but it could hit the same health system. It could hit the original one that created it. So basically 2 things could be hitting each other with their explosions and constantly taking damage. And each damage thing is creating a new explosion, and it becomes an infinite loop. And that's not what we want, obviously. The thing we failed to... I failed, obviously, to make clear is we only want this death effect once, right? You only want if we went from being alive to being dead, which is a non-reversible process. And actually, our take damage thing doesn't check for that. Take damage, the only time we check our health is after we've damaged ourselves. Then we check, is it less than 0 now? Then create an explosion. Sounds good in theory, but actually we should also check, were we more than 0 in the first place? If we were already 0 and you want us to take some damage, we don't care, we're already dead. We did our explosion thing, that's done. And, you know, even though we ran this destroy thing, this is a good thing to know about Unity, it's a little pitfall, is destroy game object doesn't immediately cause this entire thing to vanish from the code and never be used again. It's basically asks Unity to destroy it at its earliest convenience. And actually for the rest of that update, it's going to stick around in some ways, and it sort of exists for some purposes and doesn't for others. So you've got to be a bit careful about whether things are destroyed now. Basically, never assume that, you know, this line afterwards, after we called destroy, that this thing is actually gone. So we don't need to worry too much about that destroy function, the order that happens in, but the thing we should check is just, hey, you're asking us to take damage. The first thing we're going to check is our current health actually greater than 0? Not greater than 9, which is what I typed there. That's kind of irrelevant. And then we're going to put all of the code we had before within that if statement. So basically, if we're already below 0 or at 0, we don't care. We already did our taking damage. We don't want to trigger it all again if we're already dead and something else is telling us to take damage. So I believe that fixes the potential nasty situation. I guess it is an infinite loop. It's sort of, it's a recursive thing where explosions are triggering each other. And look at that, we've got a lovely chain reaction going now. I might have made these guys too small. I'm going to make them slightly bigger. Something like that. So let's get to weapons. We're going to, I think, let's go to our player and make sure that we know which way they're facing, because one problem with our player right now is you can't really tell. You will be able to, because we're going to add a gun to them. And I want, basically, I'm going to make a cylinder sticking out in this blue direction. Remember, blue is Z positive, it's the Z direction, and the Z direction is forwards for our purposes. We're saying that's what forwards means. And obviously we want the gun to face in the direction that the player is facing, and as a bonus it'll make it easier to tell which way the player is facing. So I'm just going to right click on the player and say create empty, and you might remember when we did the enemy spawner, I was saying this is a good thing to do in general, is you want to things should really have an empty game object as the main object. And then any like cylinders or cubes or whatever, like visual elements you want to add, make them as new objects that are children of this thing. So this is going to be our weapon, and there's just nothing in it at all. It's just an abstract thing. It doesn't have any presence at all yet, and we actually do want to be able to see it. So and just to kind of explain what happened there, I right clicked on the player and I went to create empty game object, and if you are currently right clicking on an existing object, Unity knows that you want it to be a child of that object, and a child in the hierarchy means that basically it's going to stick with it, it's going to go wherever it goes. If it gets bigger, the child gets bigger. If it gets smaller, the child gets smaller. If it turns around, the child rotates with it. Our weapon is inside the thing right now, but I'm going to do the same thing again. I'm going to right click on the weapon, and now I'm going to say 3D objects, cylinder. It doesn't look quite right yet, does it? I want that to point in the Z direction, and if I type in for rotation, if I give it an X rotation of 90, that's roughly the right direction. This is the sizing tool. I'm going to click on the middle thing and drag down to make it a bit smaller. And then I'm also going to click on the move tool and drag it forwards. And all of this I'm just doing to the cylinder. just the cylinder. The weapon stayed exactly where it is. I want the weapon to be at 0, 0, 0, that's relative to its parent, which is the player. So it's in the center of the player. That just means it's in the middle of the player. That's going to be useful. And it's just a good rule in general. I just want the base thing to be at 0, 0, 0 and have scale 1, 1, 1 and rotation 0, 0, 0. And then any visual stuff, the cylinder can be crazy values. Look at it. It's 90, 0, 0. It's 0.365 in the third dimension. It's got this wacky scale. It's a bunch of nonsense numbers. We don't care. It's a purely cosmetic thing. And its values can be all over the place. And I can add children to this. I can add multiple cylinders. I could duplicate this, and I could have one that's, I don't know, rotated differently, do all kinds of garbage and make it at all kinds of coordinates. Drag it out to the right if I like. That's all fine, but keep the weapon at 0, 0, 0. The weapon itself is going to be stay where it is. And actually, while I'm at it, this cylinder, even though it sort of looks like a physical thing, I don't want it to collide with stuff. I'm going to remove this capsule collider that kind of comes as standard, and just take it out. So our gun is going to be immaterial. It'll pass through walls, and one main reason to do that is I just don't want the bullets to collide with it, and for it to make physics awkward. I'm also going to, while we're at it, we created this ridiculous shiny gold material for our explosion. You can see in your project folder down there. I'm just going to drag that onto our cylinder, because actually it's a pretty good colour for a gun. Golden gun. And now the main sort of work we've got to do on the code side of things is right now it's our player that fires the bullet. And now we want it to be the weapon that fires the bullet. And the reason for that is I want to create different weapons with different properties, and all the player is going to do is just tell its weapon to fire. Hey, weapon, fire, please. And the weapon is going to decide whether it does fire, what it fires, how often it fires, everything like that is going to be up to the weapon. And this is a good kind of principle in general. It's a little bit cheeky of us to have the player, just this one player behavior script that handles movement and some physics stuff and shooting. Okay, those are all things that are associated with the player, but actually if we split that shooting thing off into its own class, even if we weren't planning to have sort of switchable weapons or have these weapons lie around on the level, that's something I'd like to do, is have the weapons just lying around. Even if we weren't doing that, it's still quite good to have a separate thing that's just a weapon that just deals with all the weapon stuff. There's a sort of... the name for this is the single responsibility principle, I think. I'm actually not 100% sure that's a good example of what that is. But it is true that in general it's considered sort of good programming practice to make your scripts do one thing and not be these sort of all-encompassing, multi-purpose, multi-tools that have all these different aspects to them. And yeah, another upside of that will just be once we've made weapons, we can give them to enemies. We can just drag this weapon over to the enemy and have the enemy tell the weapon to fire, and then the weapon doesn't need to know, whose side it's on, which gets kind of philosophical. So the weapon will need a script on it. So on our weapon object, and again, make sure you're on the weapon, not on the cylinder. The cylinder is just a visual thing. The weapon is the real functional thing. I just type the word weapon, I guess weapon behavior, and just hit enter. It already knows we want to make a new script because what I typed is not something that already exists, and it defaults to the right name, weapon behavior. Hit enter again, and adds it. And after a short period of respectful silence while it figures out what to do, we can now double click on it and edit it. So now we've got all the gun code we want pretty much. We just need to move it. So it's in player behavior right now. And so for now I'm just going to copy everything from here that's bullet related, that's shooting related, over to the weapon behavior. So we define this public game object bullet prefab. That's like a slot that we can drag the prefab into to define what kind of bullet it fires. We'll want that. Seconds between shots and seconds since last shot, that's all bullet related. Let's copy that, paste it in here. We do something on startup. We set our seconds since last shot to seconds between shots. In other words, we're ready to fire from the start. We don't need to wait. And then quite a bit further down, there's this little section called firing. So I'm going to copy all of that and put it in our update. Now, there is one thing we want to change already, which is this code checks the rate of fire. That it hasn't been too. We haven't fired too recently, and it also checks the fire button. Has the fire button been pressed? I don't think I want that to be the weapon's job. I don't think the gun should be paying attention to the controls. I think the player can handle the controls. So when we go back to the player behavior, now we no longer need this second since shot. All we're going to check is input get button fire, and then instead of instantiating a bullet ourselves, we're going to tell our weapon to fire. So I think that this will be a kind of a general thing for our player. Our player's already reading in control stuff for movement, and in general the player will listen to controls and then give out orders. You tell the player to fire, the player tells its weapon to fire. You don't have to do it that way, but that sort of makes sense to me for some reason. And so we want to be able to tell our weapon to fire. So how will we do that? There's a good reason to do it this way, in fact, which I'll get to. So we don't actually want... Right now this code is running an update, and so as soon as it possibly can, it's going to fire. Every time that enough time has elapsed since our last shot, we're going to shoot a shot, which actually we don't want. So we're going to make our own method. We're going to have a public void. Void means it doesn't return anything. It's not going to give back any information. It just does something. Fire. And we... I think that can just be like that for now. Just empty brackets, and now we're going to move all of this code, the actual thing that fires, into that fire script. So now we have a weapon class that we can give it a bullet prefab. We can set how long between shots, and it's going to do all the stuff on startup that the player used to do that relates to firing. On update, it's going to tick up its timer. How long has it been since the last shot? Let's keep ticking that up. And then when it is told to fire by something else, it doesn't know why it's being told to fire. It just gets an order, fire. It checks, are we ready to fire? Has it been long enough since our last shot? And if so, let's create a bullet at this position and facing our direction, and reset that clock. So now, back in our player class, we want to tell our weapon to fire. Right now we don't have a reference to our weapon, and so I'm going to make a slot for that. Public weapon behavior, my weapon. And this bullet prefab, we don't need it anymore, but I'm not going to delete it just yet, am I? Yes, I am. I was thinking sometimes it's useful to keep the old code around so that you can copy the values over, but actually in this case that's not it's not difficult to find where the bullet prefab is, right? We know where that is. But we do want to define this variable, my weapon. And so then further down, when the controls say we need to fire, then we say my weapon dot fire. Brackets, semicolon. So player just tells the weapon to fire. The weapon itself checks, can we even fire? And does so if it can. So now that we have that, once we go back to Unity, we've still got some work to do to kind of set it up the way it was. So yeah, we can now see weapon behavior. Bullet prefab is a slot, but it doesn't have anything set there. Well, the bullet's down here in the project folder, so we can just drag that in. Seconds between shots. Now, what was that value? Luckily, I didn't delete it yet from the player, so we can go back to the player behavior, and it says seconds between shots is 0.2. So I'm actually going to copy that and go to our weapon, paste that in. And then the last thing to do is that player, it has this slot for my weapon, and we want to set that to this weapon. So we just literally drag that weapon object all the way from the hierarchy over into this slot. And you might think that's a little bit weird because my weapon, the type of this slot is not a game object, and yet we just dragged a game object. The type of this slot is a weapon. It has to be a weapon behavior. When you drag a game object into a slot like that, Unity checks, does it have a weapon? It's looking for a weapon. Is there a weapon on this game object? If there is, okay, you probably meant the component, the weapon component, not the whole game object. So that's kind of nice. It knows this thing can't be a game object. I was dragging a game object in, so it intelligently figures out, oh, you probably meant the component on it. I think that might be it. Let's see if that works. Yeah, our gun still fires. We've got essentially the same behavior as before. The fact that we have a gun sticking out of us is actually kind of nice just for kind of feel. I know we could already sort of intuit which was the front face, but just being able to see it for sure is better. God, these things are scary. Yeah, that's kind of cool. So next we want to make give it different variables that we can change. While I think of it that those enemies are a bit fast, I'm going to go into our enemy prefab, and the speed, it's currently 8, I think. Yeah, enemy behavior, the speed slot, I'm going to make it 2 instead. Especially while testing weapons, it's going to be nice not to be under huge amounts of pressure. I'm also, while I remember, going to press Control S to save our scene, because that does not save by default. And so, yes, so the trickiest thing we're going to do is accuracy, because that's a key thing that you might want to vary. The other weapon I want to make, this one's kind of a machine gun. The other weapon I want to make is a shotgun. And to fire a spread of pellets, there's this neat thing that you could do that by sort of the way Doom, the original Doom, did this was a shotgun fires I think it was 4 or 6 pellets at exact intervals. It fires this very even spread, which is kind of weird. We're not going to do it that way, because if you make an accuracy variable, it can serve 2 purposes. It can both make a machine gun that's kind of inaccurate and spraying all over the place, and it can make a shotgun that fires a load of pellets at once, but in a random distribution. And that kind of looks chaotic and messy in a good way. So basically accuracy can double as spread and also accuracy. But so the reason that's a little bit tricky right now is how do we decide where the bullet goes? Well, we just give it our rotation. When we create it, we just point it the same way we're pointing, and it knows to go forwards. I don't really want to change that bullet code. The bullet might as well just go in the direction it's pointing. That seems to make sense to me. But I don't know of an easy way to modify that rotation. For one thing, we don't, after we create the bullet, we don't have a reference to it yet. So what I want to do, after we've made it and it's facing whatever way it's facing, I want to modify that. I want to, hey bullet, can you just tilt a little bit in a random direction? A random direction, random amount within some kind of accuracy variable that we set. We'll need a reference to the bullet for that. So this instantiate thing, right now it just creates the bullet, but it doesn't. We lose any way to communicate with it. So instead, before that, I'm going to write game object new bullet equals instantiate this. So instantiate is a function that does return something. It returns whatever it created, a reference to it. And we want to store that as a variable so we can talk to it. And then we want to do something like, the easiest way I know to change a rotation, I might have mentioned this before, but rotations in Unity are quaternions. What is a quaternion, you ask? Don't ask. Just don't look into it. They're 4-dimensional. It will break your brain. And those 4 components of a quaternion, it's not as simple as just changing each of those by a little bit. There's something else going on about quaternions that as much as possible, you don't want to be digging into them and changing their individual components and stuff like that, unless you really know what you're doing. I think that's actually how Unity's own documentation phrases it. Do not change these things unless you really know what quaternions are. And nobody really knows what quaternions are. So the most useful thing I know of is we can say new bullet, your transform, remember that's kind of the blanket term for rotation, position, and scale. There's a function called look at, and then we can give it just a location in the world, and it will point in that direction. And so the way we're going to do inaccuracy is we figure out the spot you're going to be pointing at and vary it a bit. So rather than just inheriting whatever way we're facing, that's not a great system because we want to be able to fine-tune it. We're going to there will be some kind of vector 3, no, that was right. Vector 3 target position, and we'll want to look at that target position. And somewhere in here, we're going to offset that target position by a random amount according to our inaccuracy. I misspelled that. I hope it's just wanting... Okay, it's not assigned yet. That's fair enough. It isn't assigned. Why isn't it assigned? Well, we don't have a value for that yet. We could reverse engineer it from our facing. We could figure out where are we facing and then go a bit in that direction and take that value. We could do that. I don't want to do that. Because I don't know, it doesn't feel like the right way to go about things. It's hard to kind of explain, but as much as possible, I want the code to describe what we want to happen, like the essence, the important part. And the important part about where a bullet goes is it's where you clicked. It's where the cursor is. And we have that information. Like back here in player behavior, we have vector 3 cursor position, and we find it. We do a lot of work to find that, in fact. And so I don't want our guns to be reverse engineering the direction to fire in. I want them to... We should just tell them. We have the cursor position. We should just tell the gun, here's the cursor position, fire at that. And so we'll actually pass it an argument, a parameter, in these brackets. We'll pass it cursor position. And if we do that, we'll get an error because right now fire isn't expecting anything. It doesn't take any parameters. So let's tell it to. In these brackets, we wrote vector 3 target position. So now when we're being told to fire, we want to know where. Where do you want us to fire? Just tell me where I'm shooting at and I'll shoot there. So we don't need to define that here. So now we create the bullet, and after it's created, we tell it to look at the position we were told to fire at, and we haven't done it yet, but we can now modify that position to be inaccurate in some way. Just to... I guess we can just test this as it is, and that'll... if this was wrong, if this is not doing what we think it is, we should see terrible behavior. But I expect we will see that the game is exactly as it was before. Another exciting day in keeping things exactly as they are. So, how would we make it inaccurate? I think we should modify its variables a bit. So, if we had a float called inaccuracy, and we set that to 1, then before we tell the bullet to look at the target position, we can change the target position. We could have the target position's x coordinate and increase it by... Now, we don't want to just add on 1 to it, because then that will always be straying to the left and basically will still be accurate, but always offset by a certain amount. And we want a random range of anywhere between -1, negative inaccuracy, and inaccuracy. So that says random is a hotline like vector and like input. So we call up the random hotline and say, hey, can you give me a random number between this and this? And the values we pass in are -1 and +1. Rather than write out 1, I've used inaccuracy because we're going to use this. We're going to refer to this value a lot, and we're going to change it as well. So we could go through and do X, Y, and Z and change them all. I don't actually think we do want to change Y, because that's up and down, and that's your bullets kind of like hitting the floor is going to make them ineffective. And I think it might be realistic to do that, but I think for a shotgun, it's better if they all stay on the roughly the right height to hit enemies, so that we're not being unduly penalized by that randomness. So target position's X position is going to be randomly modified between -1 and 1. And its Z position is also going to be offset in that way. We don't know what that will mean exactly. Like if we're at X equals 1 and the place we're facing is also X equals 1, then varying the X coordinate of where we're firing has a big effect. Varying the Z coordinate of where we're firing has no effect, because that's the line we're firing down, if that makes any sense. Like, the target position is coming closer or further away, that doesn't change where we aim. But that's okay. This isn't a perfect inaccuracy algorithm. We're doing it this way because it's easy to write. It's very simple. And it's not bad because in that situation where Z doesn't matter at all, that's okay, because in that situation, that's when X matters a lot. That's when changing your X value to 1 has the biggest possible effect. So overall, it ends up working out and looking all right. And that's our motto, basically. Cheap and cheerful. So obviously the inaccuracy value is not just going to be 1, but first we want to check, did this work? Did we actually successfully create some inaccuracy and shoot at a different position each time? And while I'm doing this, I might also... Our seconds between shots is 0.2. I think we can go lower. I think we can go 0.05. Going to make really rapid fire. And that'll let us see the inaccuracy a bit better as well. Okay, that is varying a little bit. Not very much. But so the amount is probably a bit low, but I also want to show you, as I move the cursor towards me, it's getting less and less accurate, right? It's going all over the place now, because we're modifying the position of the cursor, and the closer the cursor is to us, the more that we're always changing by 1, the same amount, or up to 1. And the closer it is to us, the bigger an effect that has. And that's obviously a little bit undesirable. It's kind of an interesting weapon concept. If you wanted to let the player have that kind of power where they can choose whether to be accurate or inaccurate, here's a cool way of doing it. What happens if I put it right on me? Oh yeah, it goes completely haywire. I can even hit myself. You can see I'm being knocked back by the bullets there. So we don't want it to be an absolute value. We actually want it to be... we want the distance of the target position to matter. The further away the target position is, the bigger the inaccuracy value we want, and the closer it is, the smaller the inaccuracy value we want. Hopefully that makes sense, because what we just saw was that currently, with a fixed absolute value, we get too much inaccuracy at close range, so we'd like a smaller value there. So we can just type vector3.distance, so calling the vector3 hotline, saying, can you tell me how far it is between these two positions? And the two positions we care about are our position, transformed opposition. Remember, our position is the same as the player, we're inside them. And the target position, whatever that may be. In our case, it's always going to be the cursor position, but, one nice thing about doing it this way is that later we could have, if the enemy wants to shoot at the player, we can feed in the player's position into here and stuff like that. And yeah, there's a bunch of different ways that can be used. So our inaccuracy is now the distance, divided by some other value. I think for starters we could try 20. So if the target position is 20 meters away, we will be using the value of 1. If it's 10 meters away, we'll be using the value of 0.5. And if it's 5 meters away, 0.25. Basically, the closer you are, the smaller this number will end up being that we just written. And 20 is an arbitrary value, but it's going to work out quite nicely. The way we've written that equation works out quite nicely, because when you come to define a weapon's stats, okay, so just to prove this is working, if I click as far away as I can, that's not super inaccurate. That's all right, isn't it? And if I click really, really close, it's the same. Inaccuracy is the same no matter where we click. So we fixed that problem. And this is a nice thing, because ultimately what we're working towards is making this a variable. We want a variable up top, a public float, and rather than writing inaccuracy, which is what we would have had to do with the old code, that's a little bit of a weird way of doing it. Like if you putting in the stats of a gun, it's more common to report the accuracy, not the inaccuracy, right? And in fact, that's what we've got. If we write accuracy here, that 20, which is an arbitrary figure, if we just put accuracy there, now when this value is bigger, we'll get less inaccuracy. When it's smaller, we'll get more inaccuracy. Something to note here, if it's 0, the game will crash. But then you wouldn't want accuracy 0, right? It doesn't really make sense. And so we could check and have a special case for that, but it's not worth it because we never want that to be true. One thing I thought about doing, we could just check here, is make sure that accuracy is greater than 0. But this is a case where I think crashing is better than avoiding the crash, because if we do that, now we avoided the crash, our code will never crash, but what we've actually said is when the player says, or whoever's working with this says they want accuracy 0, what we'll end up giving them is perfect accuracy, because the inaccuracy code doesn't run. And that's a weird result. That's just unintuitive. It will be hard for someone to understand why that's happening. I put in 0 accuracy, but I'm seeing perfect accuracy. What does that mean? It's better if it crashes, because then at least you know what happened. Like when it crashes, Unity will say, hey, divide by 0 error. You can't divide by 0. It doesn't make any sense. And it'll tell you where it happened. And you'll realize, oh yeah, you can't divide by 0. 0 accuracy doesn't make any sense in this case. Let's not do that. It's good enough for our purposes. There are many other cases where I would want to just prevent that, but it's when you prevent divide by 0, you've got to know what should happen if that is 0. Like something else should happen instead. And in our case, the easy thing to do would give a completely counterintuitive result, so we don't want to do it. And in fact, accuracy defaults to 0, so let's not have it at that. Let's make it 10. Remember, it was 20 in the test we just did, so we should see a much less accurate weapon now. Yeah, that's a lot less accurate, isn't it? And we can change all the stuff at real time, by the way, so let's see what accuracy 1 looks like. It's crazy. So you definitely don't want less accuracy than that, do you? And accuracy 100, is that perfect? It looks pretty good, but it shouldn't be completely perfect. Yeah, we still see some variance, right? Because this is not an out of 100 score, it's not a percentage, it's just a value. It has no absolute maximum. I guess if we put in 1,000, we'll probably see effectively perfect accuracy. Yeah, once you're kind of stable, I can't tell any variance there. So yeah, it doesn't really matter what the scale is here. But let's do 50. 50 is pretty good. All right. So now let's basically just kind of show why we're doing this and what the system does. If I just click on this weapon and I do Control D, I duplicate it. I've made another weapon. It's also a child of the player. It's in the same position, but we can modify these independently. So this one we just made. This one is rapid fire and low accuracy. Let's make it even lower accuracy. So it's very low accuracy and very fast firing. Then this other weapon we just created, we could make it, we give that one 1,000 accuracy, and second string shots could be something like 0.5. And we could call this one rifle. And the other one is Uzi. just to kind of remember what kind of character we've given these things. And now, if I just play the game and I fire, we're seeing an Uzi. This is a rapid fire, low accuracy weapon. We're not seeing the rifle at all, right? The rifle isn't firing. And that's because the player has a weapon variable and it's set to the Uzi. And so if we drag in the rifle, hopefully I can do it before I die, now its weapon variable is set to rifle. And what we see in practice, I'm holding down fire right now, we have slow, rate of fire, and single shot. I'm realizing now that damage should probably be a thing, shouldn't it? We don't have that as a variable yet. Yeah, we can do that. So, I wanted to make a shotgun, didn't I? So, to do that, we need another variable for a public. Have we ever used ints before? Let me quickly check. If we haven't already explained those, it's not worth explaining them for this, but no, we haven't. Okay, so that int just means integer, which is a whole number, but we don't need to introduce that idea. We can use a float as normal. Number of projectiles. That's going to be a key thing for shotguns. And if we want to fire more than one projectile, what we want to do is, in this bit, when we're ready to fire, I'll do a comment here, ready to fire, all of this fires a bullet. and we want to loop all of this. We want to do it as many times as we have projectiles that we need to fire. So if it's 5, we want to do it 5 times. If we want to loop through something, the code you write for this, it's a bit weird, but you will get used to it because it comes up quite a lot. It's 4 brackets int. Oh, we do have to introduce ints. Sorry. I'll go through and explain everything that we're doing right now. But int I equals 0, semicolon, without leaving the brackets, I less than projectiles to fire. Sorry, number of projectiles. Semicolon again, I plus plus. And then we do the curly braces, and we put all of that code in the curly braces. So, what the hell did I just write? It's a weird mess. I found it. I was quite slow to learn to write this off by heart because it's really 3 different lines of code in one. 4. Basically, it's going to say for the numbers 0 to 10, do this, this, and this. Do this that many times. And because this is 3 lines of code, I'm going to break it up that way and show you that this is 3 different statements we're making. So, first one declares a variable called I, and int stands for integer. Now, and then the next thing we do is this second line is a check. So I guess where will I put comments for this? Declare a variable to keep track of how many iterations we've done. That's why it's I, by the way. How many times have we iterated on this? And then set a limit for how high this variable can go. We don't want it to be to go more than the number of projectiles we want to make. And in fact, we're saying it's strictly less than that for a reason I'll mention later. And then run this after each time we iterate. Increase the iteration count. Yeah, we could even, I wonder if I hit, what is it, Control RR, we could call this iteration count. It'll almost always be, everyone uses I for this, and you'll normally use I, but just for clarity, and this first time we're doing it, I want to explain this variable. We declare one to keep track of how many iterations we've done. Then we say, when should we stop? At some point we must stop. That's one reason that this loop, there are other kinds of loop that don't necessarily have to stop. A for loop, you say in it when it's going to stop, and that means you can never have an infinite loop with it. You probably could, but usually they're pretty safe about that. So we set an upper limit. Don't go beyond this. And then at the end of each loop, increase the iteration count, obviously. Of course, you need to keep, if the purpose of this variable is to keep track of how many iterations we've done, we want to increase it each time. And for is this special function that takes these 3 different lines of code and it knows what to do with them. It knows, okay, run this one first, and keep checking for this one, and at the end of the loop, do this one. So it's a lot of things all rolled into one, and you get used to just writing it as one line of code, very short. You stop thinking about the individual parts, and it just kind of becomes second nature. And if we needed to, if for some reason we wanted to kind of like every projectile we create, if we wanted to give them different numbers like written on them, we could access which iteration we're on right now. If I was to do something like new bullet dot name equals iteration count, I'd have to do to string, which turns it into a word. I could do that. So each bullet would be named after the iteration that it was created on. I'm going to actually do that. Don't worry about that line of code if you don't understand it. I just wanted to mention that you can, within this loop, I can access what iteration we're on. Which one are we on? And the last thing to explain, it's a little bit weird if you've really drilled deep into this and figured out what we're saying. It's weird that we start on 0 and then we never reach 1. Like if number of projectiles is 1, we never get to 1. We start on 0 and then we just stop. And if it's 5, we never get to 5. We do 0, 1, 2, 3, 4. Why do we do it that way instead of, what we could do is say start at 1 And the check that we don't want to fail is make sure it's not more than number of projectiles. Make sure it's less than or equal to number of projectiles. And that way it would go 1, 2, 3, 4, 5. That is a completely logical way of doing it. It will work just fine. You can do it that way if you like. The only reason we do it the other way is programmers. This is just, it's one of those conventions that's been baked into programming for since the dawn of time. And I've learned that, like, for a while I did do it that more natural way where it starts at 1 and it doesn't go over the thing, and then I gave up because programming, you're going to be Googling things all the time, you're going to be looking at other people's code, you're going to be learning from other people, sometimes other people are going to have to work with your code, and it just pays to do it the way everyone else does it. Just stick to their conventions. It's weird, but we do it this way because we do it this way, and if everyone does it that way, it's easier. So yeah, we start at 0, we never go over number of projectiles, or never even reach number of projectiles, and you don't even really need to know that. Again, you get used to just writing this as second nature. It all flows into one thing, you don't even think about it, and if you are like reporting the number, you'll have to remember that it starts at 0. Okay, did that actually work? Number of projectiles is a variable. We've created a slot for that, and we haven't set it yet. So I'm just going to save this, go back to Unity. I talked for so long about loops, I kind of forgot where I was. Okay, and now how many projectiles per shot for an Uzi? 1. How many projectiles per shot for a rifle? 1. And now if let's duplicate the Uzi and name it shotgun. Again, I selected it and I did Control D to duplicate it. And shotgun, terrible accuracy, seconds between shots, quite slow, number of projectiles, 10. And just to start with it, we'll go back to the player and we'll drag the shotgun into that slot. And we'll see my weapon is shotgun. Let's see if that works. Yeah, alright. The accuracy is pretty all over the place. But that is shotgun-like. Oh yeah, and I wanted to try something. If I pause the game while, you don't have to do this, but while it's happening, I want to see, yeah, it's numbered the bullets. The bullets are 0, 1, 2, 3, 4. So that, I just did that to kind of illustrate when this code is running. This code is going to run 10 times. The first time it runs, this iteration count will be 0. Next time it runs, it will be 1, and last time it runs, it will be 9. And as it happens, we got just one spread here. These are the 10 projectiles I created, and I set their names to whatever the iteration count was when they were created. It's 0 through 9. I don't know if that's helpful, I just did it to illustrate that. So the nice thing about our weapon system is that we can change it at runtime. We can change it while it's running. And so I click on the shotgun, and let's see. The secondary shots, I'm actually going to make it much faster to fire, 0.3. Now it's like a more rapid fire shotgun. Its accuracy is crazy. Let's give it like 10 at least. And that's more recognisably shotgun-like, isn't it? I am... the accuracy thing is mostly working. I know our code is a little bit weird for accuracy. Well, okay, so... this is sort of mostly looking right. It's just every now and then I see a cluster go way off to one side, and all of them go that direction, which is a little bit weird to me. If anyone knows why that's happening, I'd be interested to know. It's not a serious problem, but if let's switch back to the Uzi. I guess you get the odd outlier with the Uzi, but it doesn't look wrong exactly. But I have this strange sense that it's as if the random numbers that run next to each other get similar results, which doesn't totally make sense. You know, nothing else is changing. My cursor position is not changing. My player position is not changing. But it almost feels like it's like a sprinkler, kind of goes from side to side. And with the shotgun, you get occasional batches kind of going really wide. Maybe it's just randomness, and you kind of the brain looks for outliers more than it looks for anything else. Or it's probably just like bullets colliding with each other in some way and doing something weird like that. But yeah, we got 3 different weapons now, and I can switch between them. And so I think that's probably a good place to stop. we can certainly mess around with this a bit as well. What happens if the shotgun has a rate of fire of seconds between shots of 0.001, just in time? Oh no, not just in time. I killed myself. Oh, that's interesting. After I died, I think an enemy got jammed in the spawner and it's causing the other ones to all spew out in a weird way. I kind of want, at some point, I want these to actually be launched from the spawner and have them like arc it through the play area. And they've all gone limp because they got no player to chase. That's fun. Let me just do that again. Okay, shotgun. Time between shots 0.001. Yeah, there we go. That's a fun thing. What if it also fired 100 projectiles? Oh, now we get some slowdown. Oh, you know what? Okay, so it's that's too much. We're creating 100 projectiles 1,000 times a second, that's asking a lot. And I think actually the reason it's not that it's I would suspect that it's probably the bullets colliding with each other that causes the slowdown. But the thing that struck me when I did that was it almost feels good that it slows down when you're firing. There's something like, I mean, you don't want slowdown in your game in general, but it's almost, I think we might have accidentally simulated a feel effect where, you know, sometimes at an important moment the game will kind of lock. It's called sleep, I think, where the whole game freezes intentionally to kind of give emphasis to a certain moment. And like, if you do a short burst and release, it does feel good because just kind of that kind of coming out of slow-mo feeling is really nice. And then I guess like anything less extreme is not going to be as fun. So if you did, I guess maybe it's fun just to do like, this would be bad, but I guess just like slow rate of fire but large burst. See there, you really see, if anyone knows the answer to this, I'd be very intrigued. That the whole batch all goes in one direction, right? It's a random direction, but they all go there. But our loop is doing the random call every time. We don't store this random variable, then apply it each time. Every iteration, we set a new inaccuracy thing. So I don't know why that is. And it's not consistent. Like, it's not like with the same player position and cursor position, they always go in that way. There might be some physics thing going on. It might be, if the bullets are colliding... Okay, let's actually look into this, because my theory is that it's something to do with bullets colliding with each other, and we can fix this. Or I can stop them from colliding with each other, and then we'll find out whether that is the problem. So let's open up bullet prefab. There's a layer variable here, and right now it's default layer. Layers are good for collisions. You can tell one layer to not collide with another layer. And so let's add a layer. And this brings up this layer list, and anywhere in a blank slot we can just type the word bullet, and that's now created a bullet layer. A counterintuitive thing you've got to keep remembering is when you do this, we just created this from the bullet, and yet we go back to the bullet, it's not on that layer we just created, it's still in default. You've got to manually tell it, no, do be on the bullet layer. And then, to make them not collide with each other, if this thing turns out to be something we need to do in a future episode, I'll explain it over again, because I'm breezing through it a bit here just to test my theory. Edit project settings, I believe it is, and physics. Project setting physics. There is this little graph for these are which layers can collide with each other, and you'll see by default everything can collide with everything. And if I want bullets to not collide with bullets, then I find bullets on this the bullet column, and I go down to the bullet row, and there's a check mark there, and I uncheck it. And I don't know if do I have to click save or something? No, I guess I just close it. And so now bullets don't collide with bullets. And so I'll be interested to see. Oh yeah, that's. Oh wait, our stats have reset, of course, because we didn't save them. Let's pause the game and shotgun. I want you to create 100 bullets. Yeah. Oh, look at that! That's way more regular. Alright, that was a bug. Okay. It was bullets colliding with each other. Although, having said that, the range... We fixed something, but we haven't completely fixed it. Because I'm still seeing the same thing, right? Let's increase the accuracy a bit to make it a bit more pronounced. They all still go in a certain range. Yeah, my puzzle is over, like, the leftmost extent of one burst should be the same as the leftmost extent of the next burst. Given that they're this tightly packed, there's something a little bit weird about this. Yeah, okay, so my question still stands. If anyone does know why that's happening, please tell me. But I'm glad we did that layer collision thing, because that has helped a lot. That's made it a lot more logical. Let's go back to Uzi. That one looks more or less the same, but it definitely helped with the shotgun. Alright, cool. I will stop there now, because I realise it ran on a bit long. But I'm glad we partially cleared up that mystery.